Hey everyone, I'm Faye, and today we're going to be talking about the distance of a point to a line and the distance between parallel lines. So today we're going to find out the distance between a point a, and a line. The only thing that you need to know is that you need to get the shortest distance between a point and a line. So the shortest distance between these two is a line segment perpendicular to the line itself. So anything that is not perpendicular will be slightly longer or longer. To get the distance between a point and a line is using this formula here, which is distance equals the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So you need to remember that the absolute value of any number is a positive. For example, number one, for example, find the distance from the point of 3, negative 6 to the graph of y equals 5x over 12 plus 1 over 3. So as you can see, this is the x and this is the y. So x1 is equals to 3 and y1 is equals to negative 6. So what we need to do now is to write it in the standard form, in this format: ax plus by plus c equals 0. To rearrange this equation into y equals 5x plus 1/3. So we're going to take everything and move it to the left side. Also 5 negative 12 x plus y minus 1 over negative 3 equals 0. Multiply everything by 12. So I cancel. So we have 12 times negative 5 5 over negative 12. So we're gonna crash out 12 and it will become 5x plus 12 times y equals 12y, and negative 1/3 times 12 is equals to negative 4 is equals to 0. So if we multiply everything by negative 1, it'll become 5x minus 12 plus y equals 0. So it has become a ax plus by plus c equals 0. And so our a is 5 and our b is negative 12. under C is equals to 4. So to really get since we already have the values of A, X, B, Y, and C, let's get the distance between the point 3 and negative 6. So here we have distance D is equals to the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Oh, squared. Okay. So we're going to so our A is 5. So again, let's substitute the values of ax plus by plus c. So our a is 5 and our x is 3 plus the value of b, which is negative 12 and negative 6 plus 4. So our a squared would be 5 squared plus so now let's do the math, of course. Times 3 is equals to 15 plus negative 12 times negative 6 is equal to positive 72 and plus 4. And 5 squared is 25 and negative 12 squared is 144. 15 plus 72 is 87. 87 plus 4 is 91. And 25 plus 144 is 169. And the square root of 169 is 13. So, and 91 divided by 13 is 6. The distance, so this is our answer. So the distance between the points 3, the distance which is perpendicular is of the points 3 and negative 6 is 6.
The shortest distance between two parallel lines is the length of the perpendicular segment between them. It doesn't matter which perpendicular line you choose as long as the 2 points are on the line. Recall that there are many perpendicular lines between two parallel lines. Notice that all of the pink segments are on the same length. So when picking a perpendicular segment, be sure to pick one with endpoints that are integers. Here is the first example of finding the shortest distance between two lines. So what is the shortest distance between y equals 2x plus 4 and y equals 2x minus 1? First, you need to graph the two lines and determine the perpendicular slope, which is negative 1/2. Find a point on y equals 2x plus 4. Let's say negative 1 and 2. From here, use the slope of the perpendicular line to find the corresponding point on y equals 2x minus 1. And use these 2 points to determine the distance between the two lines. D equals square root of quantity of 1 plus 1 squared plus 1 minus 2 squared equals 2 squared plus minus 1 squared. So you need to multiply the 2 into 2 times, so it equals to 4 plus 1 equals square root of 5, approximately 2.24 units. So the lines are about 2.24 units apart.